Hey everyone, welcome to the first video of my channel. Today we're going to be having a look at machine learning, what it is, what it's used for, and how does it work. Roll the intro. So machine learning, according to Wikipedia, machine learning is a field of study in artificial intelligence concerned with the development and study of statistical algorithms that can learn from data and generalize to unseen data and thus perform tasks without explicit instructions. So that was a real mouthful of words. So what does that actually mean? Well, in simple words, machine learning is a piece of code that is able to adapt to new information. So, machine learning is usually separated into two separate groups, right? You have supervised learning and you have unsupervised learning. Supervised learning, it takes up about 99% of machine learning applications, and it is where you have a data input, right? You have data input and a specific output is linked to it. So you're telling the machine that you have to find a connection between this input and this output, right? And once the machine learning model is being trained, hopefully it's able to take any input and then link it or predict a reasonable output. Okay, so unsupervised learning is quite different to supervised learning. It's not the most widely used algorithm. It is where you have input features, input values like supervised learning, whereas this time the difference is you don't have a specific output, right? So you just have the input values and you're telling the machine learning model to just to find connections in that data, right? You might want to ask it to cluster the data or perform any other actions on data. But yeah, it does not require any human intervention at all. And that's why it's called unsupervised learning. So in the next couple of videos, I will be covering the specifics of how linear and logistic regression works. Don't worry about just what it means yet. I'll be going over it a tiny bit this video, and also mainly in the next couple of videos. So you may ask, how much do I know about it and why am I teaching this subject, right? I'm doing a machine learning project for my EPQ. So I'm doing whether machine learning can analyze gravitational waves, right? So I'm trying to build a program that takes LIGO data, so data from large interferometers that measures gravitational waves, and then I'm trying to analyze that, right? So I'll also be making use of supervised learning for my project there. In this video, as I've said, we're going to be covering linear regression, okay? So let me just clarify first a few things before we move on. Okay, so I have already specified what supervised and unsupervised machine learning is in the intro, right? So supervised machine learning is split into two, right? It's split into regression and classification. Okay, and unsupervised is basically just clustering. So let's go over what regression, classification, and clustering is. Okay, so regression, it takes in so the summary of regression is or the definition of regression is that it takes an input, right, and it predicts it gives you an output from a set of infinite number of outputs, right? So an example would be housing prices, right?
So if you have a house that is, say, 100 meters squared, you have a house that is 250 meters squared, and you have a massive house that is 600 meters squared, right? Well, then the housing prices is going to be let's just say the housing price that relates to 100 meters squared is going to be 200 grand, right? And the housing price that relates to this is going to be 320 grand, and the housing price that relates to this is going to be 500 grand. So the housing prices could take on the value between 0 and infinity, right? Regression is a type of algorithm that finds a reasonably accurate prediction out of an infinite number of possible outcomes, right? So that's regression for you. Classification is also a type of supervised machine learning. So what that means is that you're having an input and you also have a set of outputs to train the model, right? But in this instance, the output is going to be only like a finite set of values, right? In housing prices, the output or the training examples could be a finite, infinite number of values, right? But for classification, let's just use the example of classifying whether a picture is going to be a lion or a tiger, right? So we're going to have picture as an input, and we're going to have lion or tiger, and you're going to be feeding it a lot of pictures, right? In order to train an accurate model, you're going to be inputting a lot of pictures, right? And you're going to specify whether the picture is of a lion or a tiger, right? So it's going to be binary in this instance. It could take on a few more values, like it could take on 4 or 5 more, a lot more, how should I say it, outputs, right? But there's always going to be a finite number of outputs because this is going to be qualitative and this is quantitative data, right? Qualitative is going to have a limit, right? Whereas quantitative, it can take on infinite number of values. Right? So this is, in this example here, lion or tiger, the output is going to be binary because either lion or it's tiger, right? So there's a finite number of outputs. So that's the difference between regression and classification. Clustering, I won't go into depth about what that is because I'm just not gonna go over in these videos. But I will probably cover it in videos to come in the future. And what that is that it takes a bunch of inputs and it just finds it finds data where they are like, let's say you have like values such as this, right? Clustering algorithm basically just groups this data, right? Sorry, those shouldn't be overlapping. It should be like that, right? It just groups the values. So yeah, that's the difference. Okay, so in a regression and also in classification, there's 3 steps, right, to how you train the model, right? First, you have to define a model. Then you have to define the cost. Then you have to do gradient descent. So you have to carry out gradient descent on the cost. based on the graph, sorry. So there's 3 steps, right, to how you train the model. Okay. So today we're going to be covering this and that. Okay, so how you define a model and a bit into how the cost function works. One, and this is going to be covered in video 2. Okay. So how you define a model, right? Defining a model mathematically is going to be like this. A linear regression, you know, it's in the name, linear, right? It's going to be a line that it's going to be a linear relationship between the input and the output, right? So you want to find a linear model for that. You want to model a linear relationship, right? So that's what defining the model is. Sorry, I should be probably writing the title here. Okay, so this is going to be a mathematical notation. Actually, this is the mathematical notation for linear regression. Okay, but we're not going to be using this, right? This is the gradient, and this is the y-intercept. I'm just specifying it. All right. So that's the gradient and that's the y-intercept, right? It links, so the input value x, right? It takes in the input value x, and it multiplies it by m and then plus c, right, to get the output. Okay, so that's how you define a line on the graph, right? So if you don't know mx plus c, the equation for mx plus c, I suggest you to look over some high school textbooks or some videos online of how you can do that, but I'm not going over it in this video. But that's the mathematical notation. We don't want that. We want the machine learning notation. Alright, it looks very similar, right? It's just that there's different letters. So this is going to be the machine learning. This is going to be the machine learning notation, okay? So this is the weight, and this is going to be the bias. So what weight and bias means, just don't worry about it too much. Just what you have to know is that it is basically the same as gradient, and the y-intercept always is the same as m and c. That's all you have to know, okay? It's just a different type of notation. So yeah, so that's how you define a model, right? Sorry, I should be going a bit more into what you were trying to define here. So let's say you have training points like this, right? This is going to be the housing price, and this is going to be the size of the house. So for this example, this is the function of only w. Oh, actually no, it's w plus c. Ws plus c. But yeah, so you have size and housing price, right? So size is what the input input value is. Housing price is going to be the output, right? So these points are training points, right? Because you have already specified a size that relates to a price, okay? So what machine learning does is that it tries to fit a line, right? A line of best fit. Or it tries to find the equation of the line of best fit, as we've specified up here, right? It tries to find a line so that every single time that you input a new value of x, right, Let's just not change colors because my laptop is overheating. I've tried to film 3 videos before this because yeah, I'm not gonna go into that. But yeah, sorry, I went a bit off track there. But so these points are original points, right? So circles are going to be points, new points that you have not specified. So you've trained the model, right? And say if you want to find the housing price for a size of 150 meters squared, right? It corresponds to a point around here, right? But I mean, there's no housing price. You have not specified the housing price for 100 meters squared. So therefore, after you've defined the model and fit the and you fit the line of best fit, you know, you've adjusted the parameters of x. Then you would make a relatively accurate prediction of the housing price, right? But how do we get to this line of best fit, right? How do we get there? Because you obviously don't know the weight and bias, and you don't really want to calculate the weight and bias by doing the mathematical way, by just calculating the you know, the gradient, etc. There's an easier way to do so, right? Sorry, I don't know why I got rid of that. So first you have to just define it to random WNB, right? It might equate to a line that looks like this. It could be looking like this, or it could be looking like this. But we're just going to be looking at a line that looks like this, okay? So obviously, for input value of 100 meters squared, the actual output, let's say, is 200,000 pounds, right? But the model, it predicts a value of 400,000 pounds, which is not very accurate, right? What the cost function is that this is called the loss, right? So how far away the point is, how far the predicted point is from the actual point, right? And the overall cost is the average of all the loss, right? So let's define the cost function. Okay, let's define the cost function. Okay, so we're gonna call it J. Okay, not F. J of W and B. It takes W and B in as parameters, right? And J of WB. So what J of WB is going to be. I'm just going to write the formula out first. Or actually the algorithm out first, then I'm going to explain what it actually does, okay? So bear with me for a second. I'll just write the whole thing out first. Alright, so this is quite complicated, okay, but it really isn't that complicated. So how do we find the loss, right? So this is going to be how we find the loss. The cost function, this function is also called the squared error cost function, right? Because squared, and this is loss, is also called the error, right? Squared error cost function. So it looks like this. Okay. So this is the loss. So f of x is what we've defined, right? So f of x is gonna give you a predicted output, right? Of, let's say, just 400,000, right? Minus the actual value, 200,000, right? That's gonna give you the loss. Okay. Why is it squared, you may ask? Well, if it's just to make loss a positive number, because you don't want a negative number for loss. So yeah, if loss is a negative number and you're squaring it, it becomes positive, because negative times negative is positive. And also it exaggerates large loss, right? Because squaring it is an exponent, right? So it increases exponentially based on how large the number is. So if the loss is a very small number and you're squaring it, it doesn't go up by much, right? But if the loss is very big, then the actual cost is going to be very big, right? Because you're increasing it exponentially. So what this is the sum, right? Sum of all of the loss from I equals 0 to all the way to m, which is total number of examples minus 1. Why does it start from I equals 0, you may ask? Well, that's a very good question. Because in computer science, in coding, indexing always starts at 0. Okay, so indexing in our normal daily life start at 1, right? But when you're coding, indexing starts at 0. So that's why. Ignore the 2 for now. I'll explain what that does. What the m does, what the 1 over m does actually. 1 over m basically divides the whole thing by m, right? And why you want that, you may ask, is because you want to find the average, right? Average is the sum of the terms over the number of terms, right? So you found the sum of the terms here, and then you divide that by the number of terms over here to find the average. The average is going to be the cost, right? Average loss equals cost. Just remember that, right? Okay, let's look into a bit more of what the 2 does. The 2 is useful when you're deriving the function. Why you're deriving the function is because we need the derivative of the function in gradient descent, which we'll cover later on in the next video. Okay, but just note that the 2 is there just simply for the ease of deriving the function, because when you derive a function, you multiply the coefficient by the power, right? So you multiply the whole thing by 2, which gets rid of that, because that's the denominator, right? And then the power is going to be subtracted by 1, so that equals, that, which looks a lot simpler, right? Instead of if you only had 1 over m at the start and you're doing 2 over m, right? Instead of just that, which is a lot more complicated. So it's just there just for the ease of deriving the function. Okay. So that's basically it for defining the model and the cost function. In the next video, we're going to be looking at gradient descent and how to actually shift the model so that it becomes a model that actually fits the training points well, right? Instead of just a random line that doesn't fit the training points at all, right? So we're going to look at that in the next video. Okay. Yeah.
So I hope everything there made sense. I know I went over things pretty swiftly. But yeah, that's a slight introduction to linear regression. In the upcoming videos, I will be delving deeper into linear and logistic regression, which is a type of classification algorithm. And yeah, I hope you've understood what I've said so far. I hope you've enjoyed, and I will catch you later. And also please subscribe, because this is a new channel, so please do that. Thanks.